On number 1, first thing I always do is I list my A value, which is 2, my B value, which is 7, and my C value, which is negative 3. Then I plug it into the quadratic formula. Instead of negative B, I'm going to write negative 7, plus or minus the square root of B squared, which is 7 squared, minus 4 times A, which is 2, times C, which again is negative 3, all divided by 2 times A, and A is 2. From here, I'm going to bring everything down except what's underneath the radical, and I'm going to find my discriminant. All right, the discriminant is 73. When we type in on our calculator the square root of 73, don't we get a decimal that goes on forever and ever and ever? So we are going to try to break down the square root of 73. When we try to break down the square root of 73, we need two numbers that multiply to give us 73, one of them being a perfect square. And if you work with this long enough, you are going to realize 73 doesn't break down. So I can't break down 73. And if I cannot break down 73, that means that this is my final answer, and I'm done. Step number 1 is I always list the A value, which is 5, the B value, which is 12, and the C value, which is 3. Plug them in. Negative B would be negative 12 plus or minus B squared, which is 12 squared, minus 4 times A times C, all divided by 2 times A. Bring down everything but the discriminant, so I get negative 12 plus or minus the square root over 10. The discriminant is 84. Now when we type in the square root of 84, don't we get a number, an irrational decimal? It goes on forever and ever. So that means we need to try to break apart 84. And I need two numbers that multiply to give me 84, one of them being the largest perfect square possible. And does anybody know what those numbers are?
4 and 21.
4 and 21? Sounds right. And the square root of 4 is 2. So 2 squared root of 21. So I'm going to come back over here and I'm going to rewrite this. Negative 12 plus or minus 2 square root of 21 over 10. All right, from here I'm going to zoom in on this. The top, we want to factor out the most possible. And what's the largest number that goes into 12 and 2?
6, 2.
2 goes into them, so I'm going to factor out a 2. And 2 times negative 6 gives me the negative 12. And 2 times the square root of 21 gives me 2 square root of 21. Now from here, I see a fraction of 2 over 10 that will reduce. So I'm going to reduce that fraction to 1 over 5. Now, does everybody see how there's a 1 outside my parentheses? Do I really need a 1 outside the parentheses? No. So I'm just going to rewrite this as negative 6 plus or minus the square root of 21, all divided by 5. And those are my two x-intercepts. Step number 1 is to always list my A, my B, and my C value. And then I'm plugging them in. Negative B would be negative 4 plus or minus the square root of 4 squared minus 4 times A times C, all divided by 2 times A, which is 2 times 12. I'm going to bring everything down but my discriminant, so negative 4 plus or minus the square root over 24. The discriminant is 448. Now when you guys type square root of 448 on your calculator, don't you get an irrational decimal again? So we are going to try to break down 448 into two numbers that multiply, give us 448, one of them being the largest perfect square possible. And I think it's 64 times 7, but will you guys verify that for me?
Yeah.
All right, so 64 is a perfect square, and the square root of 64 is 8 square root of 7. So I'm just going to come back over here and I'm going to rewrite this problem. Negative 4 plus or minus 8 square root of 7 over 24. All right. From here, we are going to look to factor out the most possible from the top. What's the largest number that goes into 4 and 8?
4.
4, so I can take out a 4. And 4 times negative 1 gives me the negative 4. And 4 times 2 square root of 7 gives me 8 square root of 7. Then I see a fraction right here, 4 over 24, that I can reduce to 1 over 6. And again, do I really need the 1 on the outside of the parentheses? No. So I'm just going to get rid of it and say negative 1 plus or minus 2 square root of 7 over 6. All right, step number 1 is always to list my A value, B value, and C value. And then I'm going to plug them into the quadratic formula. So negative 8 plus or minus 8 squared minus 4 times A times C, all divided by 2 times A, 2 times 4. Bring down everything but my discriminant. And what is the discriminant on this problem? 288?
Yeah.
All right. Does the square root of 288 give us a nice clean whole number? No. So we are looking to break down square root of 288 into two numbers and one big and perfect square. And does anybody know what those numbers are?
36 and 8.
144 and 2. So 144 and 2. And the square root of 144 is 12 square root of 2. All right, so I'm going to go ahead and rewrite what's in purple over here. Negative 8 plus or minus 12 square root of 2 over 8. Now, I need to factor out the most possible on the top. What's the largest number that goes into 8 and 12? 4. So we're going to take out a 4. And 4 times negative 2 gives me the negative 8. And 4 times 3 square root of 2 gives me the 12 square root of 2. From here, we see a fraction, 4 over 8, that can be reduced. So I'm going to reduce that fraction to 1/2. And again, we do not need the 1 on the outside of the parentheses, so I'm just going to rewrite that without the 1 and say negative 2 plus or minus 3 square root of 2 over 2.